Hello, my name is Rodrigo Milano, and I'm happy to be able to share with you part of my doctoral work, which we wanted to propose the description of the essential amino acid requirements of the pre-weaned calf um, relative to the metabolizable energy intake coming from carbohydrates. Uh, I'd like to start reminding you that the protein needs of the young calf are considered to be high due to the relatively fast growth and the lean composition of that growth. As right now, we express those requirements in terms of grams of apparent digestible protein per day, but we know that animals don't need protein per se, but amino acids, which are the building blocks of that protein. And for this reason, in our animals, like the lactating cow and the pig, we express those requirements in grams of digestible amino acids per mcal of ME or kilogram of metabolic body weight. And because in essence, the calf, it's a little cow with a monogastric digestive system, we wanted to use this approach to generate better recommendations for the calf. Our objective was to integrate the amino acid supplied with that of energy that as right now is considered as two different separate entities in the current recommendations. And by integrating that, generate recommendations relative to energy. So that in conjunction with the energy requirements, we will be able to calculate the grams of amino acid required for a calf. So for this, we use a data set containing 5 different serial slaughter studies in which nutrient intake, body growth, and composition was described. And here you can see the number of animals, mostly Holsteins, and different treatments describing mainly protein titration. Before we started to consider any amino acids, we first, and also following what has been proposed for swine, we first model nitrogen supplied and requirements. And once we had that on a nitrogen basis defined, we assign an amino acid profile to the different pools that we have considered in order to transform everything on an amino acid basis. With that, we model the metabolizable supply of amino acids with the net requirements using a logistic model, and the relative supply with the efficiency of use using a lot logistic model. Again, following the methodology proposed and followed for lactating cows. In addition, we included the random effects of treatment nested within study when we use individual calf data, and the one of the study alone when we use treatment means. Here, using lysine as an example, is the kind of relationship that we saw when we related supplied and requirements. Here is the fit of the logistic function. And using the parameters that we obtain and the third derivative of that function, we calculated the optimal supply. That is that sweet spot where retention and the marginal use, efficiency of use were both high. And with that, so we estimated the corresponding efficiency of use at that point that we call the optimal combined efficiency, in this case 0.4 for lysine. We follow the same for all amino acids, and here you can see that the fit of the logistic function was good, and the estimates of the optimum supplies and efficiencies. In a subsequent analysis, we related the combined efficiency with the supply relative to total ME, and so that the relationship was a negative relationship in agreement with what has been seen in lactating cows. However, we wanted to take advantage of the particularities of the calf in which the nutrients contained in the feed are conserved through digestion and represent what the calf ultimately has available for metabolism. Partitionally, and then partition that energy in the 3 main chemical components of the energy: protein, fat, and carbohydrate, and see how this relationship was affected. So when we use only the energy coming from protein, you can see that the relationship was almost gone. That it was not as strong when only energy coming from fat was considered, and that was tied and kind of exhibiting a curvilinear relationship when carbohydrate Amino was considered. This indicates that this relationship that we saw with total ME, it's associated for the most part to the intake of carbohydrates. And again, this aligns well with findings in swine and lactating cows that indicate that glucose and or gluconogenic precursors increase the efficiency of use of protein. And this is mainly due to the effect that glucose has on insulin and the downstreaming effect of insulin in protein synthesis. So it makes sense. Then using this relationship here, then we use that for our subsequent calculations. That here we are exceeding pretty much the same relationship, but now using the treatment means. Here is the log logistic fit of that relationship. And using our previously calculated optimal efficiencies, we calculated what was the corresponding relative supply, that in this case will be 19 grams of metabolizable lysine per mcal of carbohydrate Amino. We did that for the rest of the amino acids. Again, here's there was a good fit. And here, these relative supplies will be then the estimates that we will propose as the requirements for the calf. In this case, as reference, we thought that the best reference could be the relative content in the same metric that is found on milk, which I think should be the gold standard for the calf. And we were happy to see that they resemble pretty well in general, which gives a biological kind of like support to our approach and calculations as well. So as conclusion, I remind you that we estimated optimal efficiency use for amino acids in the calf. That we saw that the efficiency at which calves use amino acids is energy dependent, particularly that energy coming from carbohydrates. And based on this, we were able to estimate optimal relative supplies expressed in grams per megacal of carbohydrate Amino. That could be considered the requirements and could assist diet formulation. How? Well, we think that based that the energy requirements are calculated as a function of body weight and targeted gain, and that the composition of milk or milk replacer is known, the megacalories coming from carbohydrates could be calculated, and in conjunction with our estimates that we're proposing, then the grams of amino acids that particular calf eating that particular diet could be estimated in this way. So it's promising. Definitely, this needs validation. But for now, at least, we feel happy that we're providing new recommendations, probably better than the ones we have right now. So with this, I want to thank my group and the supporters that partially funded my program, and thanks to you for your attention as well. Bye.